This is the Bruker D8 Discover diffractometer system. It has a cobalt X-ray source. In fact, it's got a series of X-ray tubes. We can use chromium or we can use copper, depending on the nature of the materials we're studying. This can operate in a line mode or can be rotated to operate in a point source mode. The X-ray beam comes through here, goes into our primary optic, and in this case we've got a set of divergence slits in. It is then placed onto the sample, and in this case we've got a couple of sharpies which are ferritic and austenitic in nature. So our recorded diffraction pattern looks like this, and as you can see it looks like a duplex pattern of the two materials. From the diffraction of the sample, we have the diffraction side optics, which we can put slits or absorbers in, and we've also got our K beta absorber. In this case it's iron. Then we have a set of parallel foils or solid slits if you wish, and on here we have the link side 1D detector, which is actually a very nice detector. It gives us very good data very quickly. So with this system we can change out the primary optic instead of just using divergence slits where we have a range of different sizes. We can also switch to a polycap optic that will allow us to basically take our line source, or in this case we can actually rotate to give us a point source, but to turn that from a focusing point source to a parallel beam. And we've got a global mirror that lets us take our focusing line source and then change that to a set of parallel beams as well. And with our point sources we've got a series of collimators that we can use to bring down the size, and with our line source we've got our in-house designed by me and built by me set of masks that allow us to put the finite width on the sample side. The goniometer itself, the system is really like a Swiss Army knife, and you can throw in pretty much any size, shape, type of sample of any different types of materials and just get on and get something collected. We have a XY motor assembly here that gives us up to plus or minus 40 mil of travel, so we can take all sorts of large samples or multiple small samples and measure them automatically. We also have a Z height translation that gives us about 2 mils of translation, so we can adjust for surface changes and alignment. And we also have a chi, partial chi circle here that lets us come off axis, and a phi rotation here. So we can do pole figure analysis with this system as well as conventional diffraction. And with the parallel beam optic we can also do grazing incidence work quite nicely as well.